Hi everyone, hope you're well. So we're still going through the Practical Electronics for Inventors book. This one's the 4th edition, and the main reason I'm doing it is so I can learn about AC electronics, or AC electricity, I should say. Alright, so in the last video, we started AC resistors, RMS voltage and current, and we was just getting now to the juicy part, which is the definition of RMS right here. So let's get straight into it, and I'm gonna try and keep this video short, but the thing is it takes me a long time to understand concepts. So yeah. That's the thing. Well, what can I do? All right, so the measurement that is used instead of the average value is the RMS, root mean square value. Okay, so root mean square. Okay, and so this is found by squaring the instantaneous values. Instantaneous meaning each individual value, right? So this found by squaring each value of the AC voltage or current. Each value of the AC voltage or current. Okay, so found by squaring each value of the AC voltage or current, then calculating their mean. Okay, so let me try and put this into like a step by step thing. So it's found by, then what I can do is I could move this down here. I could go number 1, squaring each value. This, what you have to love about the iPad. I say it in every video, so apologies if you've heard me say it before, but it's too good, man. You know, taking notes on the iPad, too good. I love it. All right, so squaring each value of the AC voltage or current, and then number 2, calculating their mean. Calculating mean, or I love it. They put, look, i.e. their average. Thank you. And finally taking the square root of this. Taking the square root of all of this. Okay. Which gives the effective value of the AC voltage or current. Okay. So this gives the effective value of the AC voltage or current. Okay, so these effective or RMS values don't average out to be 0 and are essentially the AC equivalent. So RMS is the AC equivalent. Is the AC equivalent. Where am I? This one I need to highlight. Are essentially the AC equivalents of DC voltages and currents. AC equivalent of DC, D and I. Yeah. The RMS values of AC voltage and current are based upon equating the values of AC and DC powered. Okay. They're based on equating the values of AC and DC power required to heat a resistive element to exactly the same degree. Yeah, I understood the words, but I'm not sure I understand the concept. But okay. RMS values are based on making the AC values equal the DC value that, all right, is this is making sense? DC power. The RMS values are based on making the AC values equal the AC voltage or current equal to the DC equivalent, maybe DC power needed to heat the power needed to heat resistive element. What's a resistive element? Just anything that has any component that has resistance. Needed to heat resistive resistive. Okay, let's try and find what correct definition this element is. There you go. The resistive element is a resisting sudden change what position in mechanical system or change in electrical charge for electrical. Resistive element acts as a damper. Example. Inductors are also essentially resistive elements. The resistance of inductor is given. Hmm. Yeah, I'm not really following. Uh, I'm a bit stuck on that one, but that's fine. Okay. I'll just take it to mean a component that has resistance. If I'm wrong, let me know, please. And actually, I would really appreciate it. And it's a bit long, but if you hear me say something and that what I've said is totally dumb, please let me know because I can go back and correct my notes. And then obviously when I'm building my questions and that, I'll have correct definitions, which is, the whole purpose of what I'm trying to do here. So, yeah, man, I don't mind some free advice. I'm a bit cheap me, so I don't mind getting some free tutoring if you're offering. All right, so how I needed to heat a resistor element to the exact same degree, basically, to the exact same degree. Make sure that I'm Celsius. The peak AC power required for this condition is twice. The peak AC power required for this condition is twice the DC power needed. Okay. I'm gonna have to take your word for that. Power. We're talking about power, right? Okay, so there was a graph that they had somewhere. When we take a look at that, maybe that. This is the power, and as you can see, it is double. Wait, what does it say? Peak AC power required for this condition is twice the DC power needed. Okay, so we don't have DC power in here, do we? No. You can see the peak power is quite high, but yeah, I don't know. Okay, let's take your word for it. Peak AC power. Don't know what this means really. Is 2 times DC power. So I just Google that and just see what comes up. Peak AC power is double DC power. Okay, so root mean square came up, which is right. Hmm. This is crazy. Look at this. Like, this is being taught. What's this higher? I don't know what higher is, but this is GCSE, right? So kids actually learn about this in GCSE. I didn't learn about any of this when I was doing my GCSEs. Ah, man. You see what I mean? Like, this is the first time that I'm hearing of this. I was doing my GCSEs in 2007. So this is the first time I'm hearing of this. And there's a kid obviously in my class or in my uni that they were taught this, 2-3 years ago. Uh, Sucks to be a mature student, but is what it is. What can you do? At the same time, there's some clear benefits as well. So it's good. Like, bloody hell, I would not want to be living in a university dorm with 15 other people with all this health situation around the world and blah blah blah, and being locked down in your building. Forget all of that. I mean, if you're from around the world, it's probably very different. But here in the UK, it's a madness, an absolute madness. Okay, I can't find anything on this. I'm looking at these results here, and yeah, never mind. Therefore, the average AC power equivalent to a corresponding average DC power is half what? The average AC power equivalent to an corresponding average DC power half what? The peak AC power. Damn. When you're just studying and it's going well, and then you're like, oh, I didn't really understand that. And then you continue, and then you hit this huge brick wall, and you're like, oh, okay. I didn't understand that little rock there, and I just went around it, but now I can't go around. Okay, let's go from the top. I don't know, maybe did I miss something? Talking about finding square root, so root mean square, which I'm fine with. Then we say the root mean square values of the AC and voltage and current are based upon equating the values of AC and DC power required to heat a resistive element. So we've discussed here how to calculate it, and now what we're saying here is that these values that we know how to calculate, they're based upon trying to get the AC power needed to heat an element, component or whatever, to the exact same degree, and making those AC values equal to DC values, and then the peak AC power required, the peak AC, so the maximum amount of power required for AC. I feel like I feel like I remember there being DC power stuff that was mentioned in my lecture last year, and I didn't really understand it. We didn't get tested on it, so I just skipped over all of it. Um, that maybe because I don't understand the DC power part of it, maybe I'm not understanding this AC power part of it, because there seems to be an assumption here. And the thing is, this is the problem when you don't go through the book from page one. I scrolled through the book, but I didn't obviously read it, so I might have to go back and try and read the power bit. Um, the peak AC power required for this condition is twice the DC power needed. E equals VI. So let's say you had a 12-volt circuit with 1 milliamp. So you're saying 12 watts. watts of power, saying that peak AC power required is double DC power. So let's say 24 watts. Therefore, the average power equivalent, half the average, works out to be 12 because of the fact that we've just doubled the peak 24, and we want the peak is always double, right? And then we're saying that, well, wait, hang on a minute, we want them to be the exact same. We want to equate the values, so it needs to be half. Is that what we're saying? I think that's what we're saying. That makes sense to me, but I've just pulled that out of thin air. All right, I'm gonna run with it. Sometimes in life you just gotta pull stuff out of thin air and run with it. So how do we write this down into any sort of understandable notes now? I don't even know if I can just recall what I just said. Okay, so peak AC power is 2 times DC power, right? So we want AC, like average power, or is it RMS AC? RMS values. Okay, we want RMS values of AC, DC to be equal. Therefore, I don't like writing therefore like this. But to do dots. Need to get into doing symbols again in my notes. Therefore, uh, average AC power is equal to half peak power. Okay, I'm gonna go with that. If that's correct, let me know, please. Okay, so now we've got an equation here. Power average. So the thing is, when you're learning things, sometimes you can. This is a bit mad, but even if that is not correct, what I've just written, and that's wrong, as long as I'm not teaching, it's fine. Because if it helps me learn the equation for calculating the power average, right, and I just learn, okay, I take the peak and divide it by 2, and I've come up with some absolute garbage explanation as to why we take the peak and divide it by 2. As long as I'm not teaching you, which, like I said, you're learning with me and I'm not teaching you because I don't know what I'm doing, clearly. But if I'm not gonna go into lecture halls and start teaching, which I have absolutely no desire to do ever, I'm not gonna do. If I do a PhD, it will be in many years' time, and I'm still not gonna teach in lectures. But mostly because I don't like the university system. I would enjoy teaching. I just don't like. It's a bit crazy to me that you think about it, right. You haven't. I'm going off a side rant here, but imagine you've got a module like this whole book, and you're expected to teach it in a lecture for an hour each week for 9 weeks. So that's 9 hours of ripping through this book. Like, it's just not. No, like, come on. Imagine they taught you algebra in school just for 9 hours. Anyways, so yeah, as long as my nonsense explanation helps me memorize or helps me learn this equation, and I manage to use the equation fine, then it doesn't really matter if I've built up a fake little fairy tale story to help it make sense to me. So, but again, like I said, I would appreciate if you tell me that I'm wrong here. All right, so power average is equal to power peak divided by 2. And this is the reason why you can't really. I get, the whole university is supposed to be self-study, Hamid. What are you talking about? But look, I'm self-studying here right now. I'm going through a book, and it doesn't make sense. And it doesn't matter how many books I open up, it's gonna be the same thing. Like how different are these books really? They're not that different. Okay, so power average is equal to the power peak divided by 2. And we've got in brackets here, average DC power equivalent of the AC waveform. Okay, I don't know why these brackets are here. Average DC power equivalent. Okay, so I'll just put, I won't get the brackets, but let's put, this is the average DC power equivalent. Put this in commentary. Okay, mathematically, we can determine the RMS voltage and current values for sine waves. Okay, so that's our voltage expression. That our current. Okay, yeah, that's just the current expression, basically just replacing V's with I's. Oh man, crap. So I don't know how to do this. Are these functions or are these summations? I don't know how to do these. I tried to learn last year and I didn't get anywhere. So uh mathematically we can determine the RMS voltage and current values for sinusoidal waveforms. 1 over what? Yeah, I just don't understand that. I can't. Yeah. I feel like this is the this is like summation symbol, but I don't know, man. All right, so basically, I'm gonna have to stop this video here because I'm gonna have to go on YouTube and learn what this symbol means and try and do some math problems to make sure I understand it. And this happens to me. This happens to me often. So I'm not. As soon as I saw it, I was like, okay, I know what I need to do. I have to stop studying here, um, and go and learn what this is basically. And obviously that's maths, and I don't really. I've considered doing some maths videos here and there, but I don't think anyone wants to watch me learn maths. Like no one wants to watch anyone learn maths really. They want to watch people who teach maths. So once I learn a concept, I don't mind teaching it. I enjoy teaching, but as for if I spend the next half an hour now watching this, I don't think you're gonna enjoy it at all. So yeah, I'll end this video here, and I'll pick back up once I've figured out what this squiggly line and T and 0 and the rest of this jazz magaz means. So yeah, bye guys, thanks for watching, and yeah, I appreciate it. Leave a like, and I'll see you in the next one. Peace.